Welcome to another video on my channel. For this video, I'm going to introduce you to matrices. So all the foundation that you need to understand matrices will actually be explored through this video. Alright, so if you're new to the channel, please remember to subscribe so that you can be kept up to date with new uploads. And also remember to like the videos, comment, and also share with family and friends. Alright, so let's move into our first session. Alright, I'm going to start with this, and you're probably wondering what connection does matrices has with this medal count right here. And you might watch the Olympic Games or some form of track and field events and see when they are showing you which country got a certain amount of medals and a specific medal, right? So we're going to be looking at 5 countries and also explore the class of award that each country received. So for this first one, this is gold, silver, and bronze. R-O-N-Z-E. So we have China, Russia, Brazil, Poland, and France. Right here you can see that China received 133 gold medals, 64 silver medals, and 42 bronze medals. France received 51 gold medals, 53 silver medals, and 57 bronze medals. Brazil received 21 gold medals, 31 silver medals, and 36 bronze medals, and so on. So what this table does is actually give you a systematic breakdown of how many medals each country got and the type of medals that they got. We're just gonna pay attention to these 3 sections right here, and you're gonna see how this is linked to matrices in a few. If we should move over now and have a look at this. Look at this definition. A matrix is a rectangular arrangement of numbers into rows and columns. Rectangular arrangement of numbers into rows and columns. Now let us look at this more basic representation. We're looking at Russia and France. Alright, so France got 4 gold medals, they got no silver medals, and 6 bronze medals. Russia got 2 gold medals, 3 silver medals, and 5 bronze medals. Right, so let's represent this matrix as M. M for medal. So M would be equal to 4, 0, 6, 2, 3, 5. So you see how we just took this and transferred it into a more mathematical matrix form. So let's move back to the table that we were looking at first. If you notice, if I should put brackets around these numbers right here, then you can see how this 1, 2, 3 sections are related to this. This is a more mathematical kind of representation, but it's the same concept, same principle that is in the tally chart whenever you watch the Olympic Games or any form of track and field. So whenever you see anything like this again, just remember that you're looking at a matrix, a mathematical matrix. Alright, so let's move on to Jamaica. So let's use J for Jamaica. So this matrix will be J would be equal to 5, 4, and 3. So 5 gold medals, 4 silver medals, and 3 bronze medals. It is getting more mathematical now, so I wanted to see the connection. Take a look at this again. If we say country A and country B, we can represent this as, we can use any letter to represent the matrix. So we can call this even matrix A. This will be equal to 2, 4, 1, 7. And this is called a square matrix because it has the same number of rows as the number of columns, and we're going to explore rows and columns in a few. Right, so 1, 2, 2 rows and 2 columns. We're going to explore that. And looking at this, points awarded for first, second and third position in a certain race. If you come in first, you get 10 points, second 5 points, and third 1 point. So let's use P to represent this. P for point. Points. So 10, 5, 1. And this can be called a column matrix. Column matrix because it has only one column. We're going to go to rows and column. And this can be called a row matrix because it has one row. So row matrix. Alright, so we're going to move a step further now. Dimensions or size. Metric dimension or size. Whenever we speak about matrix dimension, we're speaking of the size of the matrix. And the size of the matrix is the number of rows times the number of columns. Right? Row by column. And the rows of a matrix moves from left to right. So all these numbers that you see going across. So row 1, row 2, row 3. So this has 3 rows. And the columns go from top to bottom. Bottom to top. So column 1, column 2. Remember now, dimension of the matrix is row by column. So how many rows do we have here? 1, 2, 3. So 3 rows by how many columns? 1, 2. 2. So this is a 3 by 2 matrix. This is the dimension of the matrix. A 3 by 2. Right? As simple and straightforward as that. Remember, if you have any questions about anything that I'm doing, please feel free to leave them in the comment section so that I can respond to them. Activity. Let's look at this now. Write the dimension. Let me correct this. Need a little n. So, write the dimension of each matrix below. Remember the same row by column procedure that we carried out. Let's now count the rows. Now remember, dimension is row by column. And rows go across, and column go from top to bottom, or bottom to top. Alright, so let's look at the first one now. Let's count the number of rows that we have here. 1, 2. So this is row 1. And this is row 2. Let's now count the number of columns now. From top to bottom. Column 1, column 2. So we can put this as C1, C2. So 2 rows, 2 columns. So the dimension of this matrix is a 2 by 2. Dimension or the size, a 2 by 2. Let us look at number 2 now. How many rows do we have going across? 1, 2, 3 rows. Alright? Row 1, row 2, row 3. How many columns do we have going from top to bottom now? Or bottom to top? Let's count them. 1, oops. Let's count those now. So we have 1, 2, 3. Alright? So 3 columns. Column 1, column 2, column 3. So we have 3 rows and 3 columns. So the dimension of this matrix is a 3 by 3. Moving along now, I hope you're getting the concept of this. Let's check how many rows we have in this matrix. If you notice, we only have 1 row going across. And let's now check the amount of columns that we have now. 1, 2, 3, 4. So 1 row, column 1, column 2, column 3, column 4. So 1 row going across, 4 columns going down. So this is a 1 by 4 matrix. Hope you are getting the hang of this now and see that this is very straightforward. Alright, so let's look at this fourth example now. Let us count the number of rows that we have. So 1, 2, 3 rows. And how many columns? Take a look and tell me how many columns. Good. We have 1 column. 1 column going down. So row 1, row 2, row 3, and we just have 1 column. So this is a 3 by 1 matrix. Alright, and to the final one now, number 5. Let's count the amount of rows that we have going across. 1, 2, 3. Alright, so row 1, row 2, row 3. Let's now count the amount of columns going down. Oh, use a different color. Count the amount of columns now. 1, 2, 3. Alright, so that is column 1, column 2, column 3. So we have 3 rows and 3 columns. So the dimension of this matrix is a 3 by 3. And whenever you have the same number of rows as the same number of columns, we refer to the matrix as a square matrix. Square matrix. So same number of rows. So same number of rows as columns. So this that has two rows and 2 columns, this is also a square matrix. 3 rows and 3 columns, square matrix. But this is not a square matrix. This is what we call a row matrix. Row matrix, because it has only 1 row. And then refer to this as a column matrix, because it has only 1 column. Alright, so I hope that you understand the basics of matrices in terms of what matrices is and how they can be represented, and also how to determine the dimensions of a matrix. Alright, so thank you very much for watching. Please remember to share the videos and subscribe to the channel so that you can be kept up to date with future content. So thank you very much, and look forward to my upcoming videos where I'll dive deeper in matrices, giving you some better explanations and in-depth tutorials as to how you can do well in this topic. So thank you very much for watching.